Good day, everyone. Welcome back to our YouTube channel at Smart Edu TV. Today, we are going to be looking at heat and thermodynamics. Heat and thermodynamics. And the first thing we are going to be looking at under heat and thermodynamics is thermometry. Thermometry. Under thermometry, we are going to be looking at different scales of temperature. We are also going to be looking at thermometers, their thermometric property, and how to convert from one scale of temperature to another. Talking about the Celsius scale, the Fahrenheit scale, and the what? And the Kelvin scale. So please sit back, relax, and let's enjoy this together. Starting with thermometry. What do we mean by what? Scales of what? Temperature. What are those things by which a scale of temperature depends on? A scale of temperature depends on three things. It depends on what? Three things. Number one, it depends on the thermometric property. It depends on the what? Thermometric property. Number two, it depends on two fixed points. And number three, it depends on what? Numerical scale. So these are the three things in which a scale of temperature depends on: the thermometric property, the two fixed points, and a numerical scale. What do we mean by thermometric property? A thermometric property is a physical quantity that is monotonic increasing. That is monotonic increasing or decreasing with what? Temperature. A thermometric property is a physical quantity that is monotonic increasing or decreasing with temperature. That is what we mean by what? Thermometric property. It is this thermometric property that makes different thermometers to be suitable for different functions. It is this thermometric property that allows us to prefer a certain type of thermometer over another based on what? On little what? Differences due to their thermometric property. These differences can be either what? A wide range of temperature or a low range of what? Temperature. So this thermometric property is very important dealing with what? Thermometers. The second thing we are going to be looking at here is what? Is the two fixed points. What are the two fixed points on temperature scale? These two fixed points we are talking about are the upper fixed point and the lower fixed point. The upper fixed point is also called the boiling point, or we can also call it what? The steam point. While the lower fixed point can also be called the freezing point or the ice point. The ice point. So these are the what? The two fixed points we are talking about under our scales of what? Temperature. And the third one here, we have the numerical scale. What do we mean by a numerical scale? A numerical scale is simply a readable scale that is attached to every thermometer. A numerical scale is a readable scale that is attached to every what? Thermometer. Without the what? The gradation, it won't be easy for us to actually read that thermometer. So due to the gradation, it allows us to read different thermometers easily. So these are the three things upon which a scale of temperature depends on. So after understanding this, we are now going to be looking at the thermometric property of different thermometers. I'm going to be listing different types of thermometers with their corresponding thermometric properties. What property gives them edge over others? We are going to be looking at that now. So I'm going to draw it in form of a table showing the types of thermometer and their thermometric property. Showing on the board are the different types of thermometer with their corresponding thermometric property. The first one, as you can see here, is the liquid in glass thermometer. Liquid in glass thermometer. And its own thermometric property is the length of the liquid in the capillary tube. The length of the liquid in the capillary tube. The second one is the constant volume gas thermometer. Constant volume gas thermometer. And its own thermometric property is the change in pressure of a fixed mass of gas at constant volume. Change in pressure of a fixed mass of gas at constant volume. The third type of thermometer that we are looking at is the resistance thermometer. The resistance thermometer. And its own thermometric property is the resistance of a coil of wire. The resistance of a coil of wire. The next is the thermoelectric thermometer. Thermoelectric thermometer. And its own thermometric property is the electromotive force of a thermocouple. The electromotive force of a thermocouple. The next type of thermometer that we also look at is the absolute thermometer. The absolute thermometer. And its own thermometric property is mercury. Mercury. We also have the clinical thermometer. Clinical thermometer. And also its own thermometric property is mercury, as well as the bimetallic thermometer. Bimetallic thermometer, whose thermometric property is also what? Mercury. These are the different types of thermometer with their what corresponding thermometric properties. We have various types of thermometers. There are more than this. These are just the little we can list out. We also have the laboratory thermometers. And its own thermometric property is alcohol. So that's laboratory thermometer, which is alcohol. So we have various types of thermometer. So it depends on what you want to measure, the range of temperature that you want to use, that will now determine which type of thermometer will be suitable for that purpose. So the next we want to look at is temperature conversions. So we want to see how to convert from a given scale of temperature to another. How to convert from a given scale of temperature to what? To another. Either from Celsius to Fahrenheit, or from Fahrenheit to Celsius, or from Celsius to what? To Kelvin. So let's start with the first one, which is conversion from temperature that is in what? Is in Fahrenheit to temperature in degrees Celsius. How do you convert from a temperature that is in degree Fahrenheit to a temperature in degrees Celsius? We make use of the standard formula that says that to find any temperature in degrees Celsius, we should use the formula 5 into the temperature given in degree Fahrenheit minus 32, everything divided by 9. So this is the standard formula we use in converting from a temperature given in what? In degree Fahrenheit to degree Celsius. For example, if I want to convert 40 degree Fahrenheit to what? To Celsius. I want to convert 40 degrees Fahrenheit to what? To Celsius. Using this formula, anywhere I see what? This temperature in degree Fahrenheit, I should replace it by what? By 40. My temperature in degrees Celsius will give me 5 into 40 minus 32. Everything divided by what? 9. So 40 minus 32 is what? That's 8. 8 times 5 is what? 40. 40 divided by 9 will give us what? 4.4. 4.4 what? In degrees Celsius. And that's our what? Final answer. That's how to convert from Fahrenheit to what? Celsius. Similarly, I can also convert from Celsius to what? Fahrenheit. I can also convert from temperature that is given in degrees Celsius to what? Fahrenheit. I'm going to make use of the formula that says for me to find any temperature in degree Fahrenheit, I should use 1.8 times temperature given to me in degrees Celsius plus 32. 1.8 times temperature given to me in degrees Celsius plus what? 32. For example, if I want to convert, let's say 10 degrees Celsius to what? To Fahrenheit. I want to convert 10 degrees Celsius to what? To Fahrenheit. So we are just going to what? Use that formula and what? And say 1.8 times 10. 1.8 times what? 10. 1.8 times 10, then the result of this plus 32. 1.8 times 10 plus what? 32. So 1.8 times 10 gives what? 18. 18 plus 32 gives 50. So this gives us what? 50 degree Fahrenheit. 50 degree what? Fahrenheit. So this is how we convert from Fahrenheit to Celsius and also from Celsius to what? Fahrenheit. What of conversion from Celsius to Kelvin and also from Kelvin to what? Celsius? How do we convert from temperature given in what? In degrees Celsius to Kelvin and also from temperature in what? In degree Kelvin to what? To Celsius. Number 3, conversion from what? From temperature in degrees Celsius to Kelvin. For us to convert from Celsius to Kelvin, we use the formula that says that what? Our temperature in degree Kelvin equals any temperature given to you in degrees Celsius plus 273. Any temperature given to you in degrees Celsius plus what? 273. So if I want to convert 10 degrees Celsius to what? To Kelvin, I'll just add 10 to 273, which will give us what? 283 Kelvin. So that means 10 plus 273, which is called 283 what? Kelvin. That's how to convert from what? From Celsius to what? Kelvin. Similarly, if I want to convert from Kelvin back to what? Celsius. From Kelvin back to what? Celsius. I'll make use of the formula that says temperature given to me in degrees Celsius to be equal to the temperature what in degree Kelvin minus 273. Temperature in degree Kelvin minus what? 273. For example, if I want to convert 300 Kelvin to Celsius. Convert 300 Kelvin to what? To the temperature in what? In degrees Celsius. I'll make use of the formula. The Kelvin here is what? 300 minus 273. And this will give us what? This will give us what? 27 degree what? Celsius. So that's how to convert from Celsius to Kelvin and also from Kelvin to what? Celsius. The next we want to look at is the 3 standard scales of temperature. The 3 standard scales of what? Temperature. That is the Celsius scale, the Kelvin scale, and the what? And the Fahrenheit scale. So those are the 3 standard scales of what? Temperature. But it doesn't mean they are only 3. They are actually what? More than 3. But the one that is what? Of interest to us under heat and thermodynamics is just 3. The Celsius scale, the Kelvin scale, and the Fahrenheit scale. We also have what? The Rankine scale. So they are what? They are more than 3. We have different what? Scales of what? Temperature. But for what? For the purpose of this course, we are going to be focusing on only 3, which is the Celsius scale, the Kelvin scale, and the Fahrenheit scale. So let me use the diagram to represent the 3 scales. So let's assume this is what? The Celsius scale. This is what? The Kelvin scale. And the last one here is what? The Fahrenheit scale. So these are the 3 standard scales of what? Temperature. So let's see what happens at the upper fixed point and also at the lower fixed point. So let's start. For the Celsius scale, the lower fixed point is 0 degrees Celsius, while the upper fixed point is 100 degree what? Celsius. For the Kelvin scale, the lower fixed point is 273 Kelvin and the upper fixed point is 373 Kelvin. And also for the Fahrenheit scale, the lower fixed point is 32 degree Fahrenheit and the upper fixed point is 212 degree what? Fahrenheit. So these are the what? 3 standard scales of what? Temperature, showing their upper fixed point and their what? Lower fixed point. And also, it should be noted that the interval that exists between the upper fixed point and the lower fixed point of any given scale of temperature is called the fundamental interval. It's called the what? The fundamental interval. That is the interval that exists between the upper fixed point and the what? The lower fixed point. Okay? So if this is what 0 and this is what 100, what of an unknown scale? Let's assume here I'm having what? X. I want to read this particular spot. I want to read this spot, let me call it what? Y. And I want to read this spot, let me call it what? Z. So let's see what happens to those what? Unknown spots. Using what? We want to try to generalize the formula that we can use to tackle any problem that involves a scale of what? Temperature. Don't forget, this is X, this is Y, and this is what? Z. For me to find what? A suitable formula that will be used to solve any problems that involve scale of temperature, I'm going to get it from these standards. From these three what? Standard scales of what? Temperature. For instance, we want to compare between Celsius scale and Kelvin scale, or between Celsius scale and what? Fahrenheit scale, or even between Kelvin scale and what? Fahrenheit scale, or I can even what? Compare the three of them. So let's try and what? Compare the three of them. Let's start with the Celsius scale. For the Celsius scale, the unknown here is what? Is X minus the lower fixed point, which is what? 0, divided by the upper fixed point is what? 100 minus lower fixed point is what? 0. Should be equal to, let's go to the Kelvin scale, we do the same thing. The unknown is what? Y. Always start with the unknown. Minus the lower fixed point, which is what? 273. Divided by the upper fixed point, which is 373, minus lower fixed point, which is what? 273. Should be equal to, let's go to the Fahrenheit scale. For the Fahrenheit scale, the unknown here is what? Is Z, minus the lower fixed point, which is what? 32, divided by the upper fixed point, which is what? 212, minus the lower fixed point, which is what? 32. So these are the three what? These are the standard formulas that you can use to solve any problem that involves what? A scale of what? Temperature. Problems that involves what? Scale of temperature usually involve us to compare two different scales of temperature. For instance, the comparison can either be between Kelvin and Celsius, or Celsius and Kelvin, or Kelvin and what? Fahrenheit, or Celsius and what? Fahrenheit. Or sometimes it can be between an unknown thermometer entirely with any of these standards. What do you mean by unknown thermometer? They will give us what? A particular thermometer that is different from these three. But in that thermometer, they must what? Define its upper fixed point and the lower fixed point. So there, once they define the upper fixed point and the lower fixed point of that thermometer, I can easily what? Compare with any of these standards based on what the question wants me to compare with. If the question is talking about Kelvin, I should compare with what? Kelvin. If it is talking about Fahrenheit, then I'm going to what? Compare their own standard to what? To the Fahrenheit. Don't forget, the lower fixed point and the upper fixed point of these three standard scales of temperature are constant. They expect us to know it. They are always what? Constant. So let's see how we solve one or two problems that involves a scale of what? Temperature, so that we can understand this better. Okay, so let's see this example. So in this example, we are told that the upper fixed point and lower fixed point of a particular thermometer are 230 millimeters and 80 millimeters respectively. 230 millimeters and 80 millimeters respectively. What is the temperature in degrees Celsius when the thermometer reads 95 millimeters? What is the temperature in degrees Celsius when the thermometer reads what? 95 millimeters. Before you solve any problem like this, always sketch your what? Diagram. Always sketch your what? Diagram. So look at the question very well. We are given what? A particular what? Thermometer. You can see it's not part of the three standards. They define the thermometer for us. and its upper fixed point and lower fixed point are 230 millimeters and 80 millimeters respectively. Respectively simply means that the first figure here, 230 millimeters, is the upper fixed point, while 80 millimeters represent the lower fixed point. Don't forget, either they call it upper fixed point or they call it what boiling point or they call it what the steam point. They mean the same thing. So they can use any of them. It's their choice. So, and also for the lower fixed point, either they call it what the lower fixed point or they call it what the freezing point or they call it what the ice point. Please always take note of these words. They are very important. And we are comparing this particular thermometer with what? With Celsius. Can you see it? We are comparing it with what? One of the what? Three standards, which is what? Celsius scale. That means I'm comparing these parameters given to me to that of what? Celsius. So I'm going to what? Draw the what? The two scales. One in what? In mm and the other one in what? In degree what? Celsius. So let's see what happens at the upper fixed point and also what happens at the lower fixed point. For the particular thermometer that is calculated in millimeters, the upper fixed point is what? 230 mm. 230 what? Millimeters. And the lower fixed point is what? 80 millimeters. For our Celsius scale, the lower fixed point is what? 0 degrees Celsius. And the upper fixed point is what? 100 degrees Celsius. What happens again? So we are told that what is the temperature in degrees Celsius? We are looking for the temperature what in degrees Celsius. Let me call it what? Let me call it Y or X or any letter. We are looking for what is the temperature what in degrees Celsius. Want to know the temperature in degrees Celsius? When the thermometer reads 95 mm. So when this particular thermometer is reading what? 95. If this is 80, 95 should be what? Slightly above what? 80. So let's assume here is what? The 95 mm. So now, based on the what parameters given to us, we have this sketch. So from here, we can what bring out our what our formula in which we can use to solve this. So looking at our formula, don't forget always start with the unknown. I can start with any of them. Let me start with the particular thermometer. Here I'm having what 95. The unknown here is what 95. 95 minus the lowest. Don't forget 80 divided by what the highest minus what lowest. The highest is what 230 minus what the lowest is what 80. 80 should be equal to, let me compare this one with the Celsius scale. For the Celsius scale, the unknown, always start with the unknown. The unknown is what? Y. Minus what of the lowest? The lowest is what? 0. Divided by the highest is what? 100. Minus what? The lowest is what? 0. So this is what? Based on what? The parameters given to us, we have this. What is 95 minus what? 80. This gives us what? 15. Divided by what is 230 minus 80. This will give us what? 150. 150 equals, this gives us what? 12 minus 0 is what? Y. Divided by 100 minus 0 is what? 100. So we have these two what? These two sides. So that we can what? Cross multiply. When we cross multiply, 15 times 100 gives what? 1500. To be equal to 150 times that gives what? 150y. Since I'm looking for what? For y, I can divide both sides by what? 150. So that 150 cancels what? 150. Therefore, the value of y is going to be equal to what? 0 cancels zeros. 15 is what? 1. 1 and 0. So we have what? 10. The value of y is what? 10. 10 what? Is it 10 millimeters or 10 degrees Celsius? Go back to your what? To your diagram. Y is what represents the Celsius scale. So I'm having 10 degree what? Celsius. So that particular thermometer is going to read what? 10 degrees Celsius corresponds to what? 95 millimeters. And that is how we solve a problem like this. That is how we solve a problem like this. As you can see, always sketch your what? Diagram. Always sketch your what? Diagram. Example 2. Example 2. A resistant thermometer has a resistance of 10 ohms at 273 Kelvin and 70 ohms at 373 Kelvin. If it records 55 ohms in a certain medium, calculate the temperature of the medium. Calculate the temperature of the what? Medium. So we can see this. Also, we are having what? A resistance thermometer. So we want to compare that of resistance thermometer with that of what? Kelvin. You can see between a particular thermometer that is not known, but it is called what? A resistance thermometer. If you look at the question very well, its fixed points are well defined because they said it has what? 10 ohms at where? At 273 Kelvin. This implies that at the what? At the lower fixed point, it corresponds to what? To 10 ohms. Also, at the what? At the upper fixed point on the Kelvin scale, it also corresponds to what? 70 ohms. They are now asking us that if that resistance thermometer records 55 ohms in a particular medium, they want us to calculate the temperature of that medium. Don't forget, always sketch your what? Diagram. So let's sketch this what? Diagram. We have two scales. One is what? Resistance, while the other one is what? Is Kelvin. So this is what? Resistance is what? In ohms, and the other one is what? Kelvin. So what happens at their what? Upper fixed point, and also at their what? Lower fixed point. So let's see what happens at what? At the upper fixed point. For Kelvin scale, don't forget the standard. This is what? 273 Kelvin, and this is what? 373 what? Kelvin. For the 273 Kelvin, it corresponds to what? 10 ohms on what? On the resistance scale. So this is ohm. This is symbol for ohms on the resistance scale. So this was 10 ohms. 10 ohms. And also 373 Kelvin corresponds to what? 70 ohms. So this corresponds to what? 70 ohms. So now they are now asking that if it records 55 ohms in a certain medium. If this is 10, then 55 should what? Should not be up to 70. Let's assume 55 is around here. 55 what? Ohms in a certain medium. Calculate the temperature of that medium. I want to know the temperature of that medium. Let me call it what? Z. I can use any letter. I can use X, I can use Y, I can use K, I can use no, don't let me use K because of Kelvin. I can use what? C, I can use any letter. Provided that what? I'm interested in what? In knowing the value of that letter. So now, always what? Follow the standard. What is the standard? Let's start from the resistance scale. For the resistance scale, the unknown here is what? 55 minus the lowest is what? 10 divided by the highest is what? 70 minus the lowest is what? 10 should be equal to, let's go to what? To the Kelvin scale. The unknown is what? Z minus the lowest is what? 273 divided by the highest on the Kelvin scale is what? 373 minus the lowest is what? 273. So what is 55 minus 10? 55 minus 10 gives what? 45 divided by 70 minus 10 gives what? 60 should be equal to Z minus 273 divided by what is 373 minus 273? This gives us what? 100. Also, we what? We cross multiply. When we cross multiply, 45 times 100 gives what? 4500. 4500 should be equal to, put these guys in brackets. 60 is multiplying the whole of this bracket. That is, the 60 will multiply Z, and also the 60 will multiply what? 273. When 60 multiplies Z, we have what? 60Z minus, when 60 multiply what? 273. We are going to have 16,380. 16,380. Okay? So that if I what? When this goes to the other side, it becomes what? Positive 16,380 plus 4,500. 4,500 plus what? 16,380. So when we add that together, we are going to have 2880. 2880 should be equal to what? 60Z. Since my interest is to find the value of what? Of z. It means I'm going to what? Divide both sides by what? By 60. Divide both sides by what? 60. So that this 60 cancels this what? 60. Therefore, my z that I'm looking for is going to be 2880 divided by 60. So that will give us what? 300 and what? 48. 48 what? Kelvin on the Kelvin scale. 300 and what? 48 Kelvin on the what? On the Kelvin scale. So that is how we solve any problems that involve a scale of what? Temperature. Always remember, we are comparing. Either we compare with what? With a particular thermometer with any of the three standards, or we compare what? Any two standards together. It will be indicated in the question given to us. Always sketch your diagram to avoid mistakes, and you have to be what? Very careful when you are what? Cross multiplying. Always put them in what? Brackets, so that you will be what? Be aware that this anyone here is multiplying the whole expression here, not only the first one. Please take note of that. So this is how we solve problems that involve a scale of temperature.